This first part of the studio is research-based. We named it Fluidity because it is dependent upon open-minded, flexible thinking while focusing in on specific information and data. For us, research is a critically inquisitive, technical, and creative activity. The three phases of our research included individual mapping, modeling, and research, a group field trip with sight reading activities, and team research, 6 topics with 2 students per team. On campus, we met with our grant partners. On site, we met with local leaders, citizens, and characters. The research themes that then emerged were 1. Resilient infrastructure and climate change, 2. Human settlement and history, 3. Environmental systems and resources, 4. Geology, soils, and agriculture, 5. Public infrastructure, and 6. Waterways and nautical systems.
The first settlers in Greenwich were Lenni Lenape Indians, who used the land for drinking water, fishing, and hunting. European settlement began in 1638, first by the Swedes, then by the Dutch in 1654. It wasn't until 1675 when development truly began by the Quakers. Major development occurred on what is now the main street of Greenwich, Egrate Street. This street is unique to the town by profile, development, and zoning. All the structures are constructed of either brick, wood, or stone, and seem to follow the same profile of distance from the street, porch dimension, and height to match the neighboring structures. This timeline captures key moments of the history and growth in Greenwich, specifically the gradual growth in population to the now declining population. It is important to note that Greenwich had their own tea party in 1774, where the residents burned all the tea in the city center in protest against the British. A monument was erected in 1908 to honor the memory of the Greenwich Tea Party. These statistics emerge from individual research on demographics and the history of the town. The map on the left shows all the public and community structures on Egrate Street, which include an elementary school, a church, a cemetery, a restaurant, and museums.
Greenwich is a town with a number of layers of infrastructure, both past and present. More than just roadways and utility lines, infrastructure in a broader sense is the systems that are necessary for the continued inhabitation of the area. Power, sewage, transportation, telecommunications, and the availability of markets for essential goods are crucial considerations. The area used to be connected to the rest of the state by the railroad, and its access to water allowed for maritime transportation. However, over the years, the railroad has disappeared and maritime transport has largely been replaced by automotive transport. Greenwich's infrastructural considerations are numerous and interdependent. The town's close proximity to the Salem nuclear power plant is both a source of energy and concern, necessitating a system of power lines for electricity as well as a system for emergency evacuation. The low-density nature of the area, heavily influenced by its soil-bearing capacity, precludes the creation of a sewer system requiring individual septic systems for each property. The small population of the town complicates the establishment of markets and services, forcing residents to drive to the next town over for supplies, medical care, and education. All these existing systems of infrastructure will be changed to rising sea levels.
It was important to look at the environmental resources in Greenwich. This included zoning, floral, and fauna. Bordered by Stowe Creek, the Cohansey River, and the Delaware Bay, Greenwich interacts with coastal conditions that dictate the type of animals and plants that thrive in the area, as freshwater meets saltwater often. Greenwich can be categorized as marshland, farmland, or uplands. The town takes pride in its diversity of birds and aims to provide a suitable ecosystem for those that are especially endangered. It's easy to find yourself a view of Phragmites or eagles flying above. Greenwich is unique in that a large portion of it is actually part of the wildlife management areas. New Jersey is home to many endangered birds, and many of them are located in Greenwich, so the wildlife management areas play a part in their survival. On the right, the map shows where the New Jersey Bayside Track is, in orange. The Bayside Track is part of the PSEG Estuary Enhancement Program, one of the country's largest privately funded wetlands preservation efforts. With more than 4,000 acres of the Bayside Track in Greenwich Township, visitors and residents can explore and appreciate this open space. This track is where most of Greenwich's marshlands lie and holds potential for ecotourism. We also looked into the views, endangered birds, and tree types in Greenwich. Greenwich has many different environments within its political boundaries, ranging from open farm fields to the historic downtown to tree-dense patches to marshlands. One can experience a multitude of conditions in the town. Within these environments exist a collection of endangered birds of varying sizes, as well as a variety of trees and plants. The wildlife that exists here are used to its coastal location.
The food and agriculture industry in Greenwich is vital to its economy and tourism. As future floodwater encroaches on protected farmland, the town's livelihood is becoming under threat. The industry started as far back as the 1600s when European immigrants cleared forests and grew crops. In the 1800s, agriculture would develop from subsistence farming into canning, which allowed canned goods to be transported to Camden and Philadelphia. For the past century, Greenwich has shifted towards nursery farming and staple crops such as corn and tomatoes. Nearby towns such as Deerfield have developed larger farms away from the bay that are away from the threat of sea level rising. We propose specialty farming and agritourism to rejuvenate the economy and attract guests. We look to interventions like community-supported agriculture, farm-to-table restaurants, and Rutgers Food Innovation Centers. CSA, or community-supported agriculture, could help local farms in Greenwich distribute their crops to other towns outside of Greenwich. Rutgers Food Innovation Center could help farms with storing and producing mass quantities of goods to distribute as well. A strategy like farm to table would be both economic and resilient, as it would attract tourists to the area and use local ingredients. Much like the agriculture development, the aquaculture in Greenwich has played a large role in the economy as well. Currently, the town has two marinas located on the Cohansey River, the Greenwich Boatworks Marina and the Hancock Harbor Marina. Both marinas have boat launch capabilities and access to many different fish that live throughout the river. Looking along the bayside, in the past Greenwich was one of the largest producers of oysters and caviar, but due to disease and overfishing, both populations have died out. In recent years, there have been efforts to restabilize the oyster population through the Delaware Bay Oyster Restoration Project.
Evaluating this community, it was important to research water and the water management in the area. The state of New Jersey is split into 5 different water regions, with Greenwich being part of the Lower Delaware Water Region. Their watershed management area is divided into 2 different watersheds, separate from its political boundary, the Stow Creek and Cohansey River watershed. These 2 watersheds are then split into smaller watersheds, with sources from other creeks and mill ponds. In Greenwich, there is a low-lying aquifer that lies beneath the town, the Kirkwood Cohansey. The wells in Greenwich do not have to be too deep, as they can reach fresh water between 30 to 60 feet in depth. When flooding occurs, the excess water seeps into the aquifer below, causing it to overflow and add pressure. This hydrostatic pressure ultimately causes flooding issues for the basements in the town. On the right, we can observe the tidal flow on our site and how the average difference between high and low tide is about 6 feet. This tidal change occurs twice a day along the Cohansey River and Stow Creek. In the graph and table, we can observe the tidal change on the day NJIT's Greenwich studio visited the town in February. It's important to acknowledge existing methods of water mitigation in Greenwich. There are 3 existing levees that help alleviate water issues, Levee 48, 50, and 51. Working as an existing roadway on Bacon's Neck Road, Levee 48 is categorized as a metal sheet piling. Levee 50 is an embankment on Market Lane which leads to the Greenwich Marina, while Levee 51 is also an embankment with TideFlex check valves that allow for controlled flow rates. It is pertinent to consider movable water management systems that would allow for controlled flow.
There are several different kinds of designs for resilient infrastructure to draw upon, such as levees, seawalls, and surge barriers. Embankment levees and sheet pile levees are common solutions, but more innovative designs are being seen in the use of water rotors to slow flow and create energy, as well as in the work of seawalls using curved geometries to redirect flow back out. Traditionally, the concern with the design of such infrastructure has been the blockage of water, but just as important in many instances is the provision of tidal flow to marshes. It is in these circumstances that infrastructure design must incorporate operable floodgates to maintain tidal flow while allowing for protection against storm surge. Such infrastructure is constantly performing and undergoing stress, and as such requires frequent upkeep to prevent failure. Due to their size and maintenance, any such infrastructure is a large investment and should maximize on its value and effectiveness.
As you have just seen, in this initial fluidity research part of the semester, we became knowledgeable about the place through mapping and analysis of the geography, water, geology, and political boundaries. We excavated the material place with its history and human activities. We identified built and natural systems, We wrestled with cyclical forces and changing conditions. We discovered the potency of the place as a narrative and source for design ideas, and we redefined resiliency as we launched into the next phase.